Hello everyone, welcome to Physics. In this particular video, we are going to start one of the most important topic of the units and dimensions. That is dimensional analysis. Now, in dimensional analysis, first we have to learn about principle of homogeneity, which is one of the most used principle in units and dimensions. This principle states that the dimensions of each term of the dimensional equation on both sides are the same. So what this statement convey to us is that if we have one equation which is x equals to y, so dimensions of this x quantity, suppose it is ma, lb, ec, then also dimensions of y should be ma, lb, ec. This is principle of homogeneity. It means force should be equals to mass into acceleration. Here we have dimension of force as m1, l1, t minus 2, and here we have dimension of mass as m1 and dimension of acceleration is l1 t minus 2. Similarly, we can say that force equals to mass into velocity. If this kind of equation is provided to us, here dimension of force is m1 l1 t minus 2, while dimension of mass is m1 and dimension of velocity is l1 t minus 1, which is does not equal to. So this both the dimensions are does not equal to each other. So this equation is wrong. Now one of the most famous equation of Einstein, that is E equals to mc square. Here E is the energy that equals to m1 l2 t minus 2, and here mass equals to m1 and speed of light square, which is l1 t minus 1 whole square. So both the dimensions combined can be written as m1 l2 t minus 2. So left hand side and right hand side are equal, so this equation is dimensionally correct. Similarly, we have one equation which is v equals to u plus at. Here v is velocity, that is l1 t minus 1, u is again velocity which is l1 t minus 1, a is acceleration which is l1 t minus 2 into t which is t1, so it can be written as l1 t minus 1. Here we can say that the quantity of same dimensions can be added only if here we add initial velocity with acceleration, which will be definitely wrong. Hence we cannot add force to the momentum, but we can add potential energy to the kinetic energy, because the dimension of potential energy and kinetic energy is same, while this cannot be true. So this is all about principle of homogeneity. Now let us see what are different applications of dimensional analysis. Now let us look into applications of dimensional analysis. First is to obtain relation between the units of some physical quantity in two different unit system. It means we can convert one unit from SI unit system to CGS, or from CGS to SI unit system. We will see in great detail about this application. Our second application is to check the dimensional consistency of an equation connecting different physical quantities. It means if we are provided some equation x equals to y into z divided by a, we can check its dimensional consistency using dimensional analysis. Our third application is to derive an equation for a physical quantity in terms of other physical quantity. We will learn about it into the dimensional analysis.